Okay, so our Algebra 1 notes for today are on 0 and negative exponents. So our objective is to simplify exponents, specifically 0 and negatives. So our objective is to simplify exponents, specifically 0 and negative exponents. So we've got two things to talk about. We're going to start with 0 exponents. Zero exponents means there's a 0 in the exponent, so like 2 to the 0. 0 exponents is a rule that you have to memorize. Anything to the 0 power equals 1. So 2 to the 0 equals 1. 3 to the 0 equals 1. 73 to the 0 equals 1. And I know that those look like degree symbols, but they're really zeros for the exponent. No matter what the number is, anything to the 0 power is 1. So even when it's like this, negative 4 to the 0 power, that's still 1. Now the reason for that is this. If we start out with 2 to the 4th, 2 to the 4th means 2 times 2 times 2 times 2, and that's 16. We're going to look at a pattern. So if we go down to 2 to the 3rd, 2 to the 3rd is 2 times 2 times 2, and that's 8. If we keep going in our pattern, we have 2 squared. 2 squared is 4, and 2 to the 1 is 2. If we look at this pattern, going down, what do you do to 16 to get to 8? You divide by 2. What do you do to 8 to get to 4? Divide by 2. What do you do to 4 to get to 2? Divide by 2. So if we want to keep going with our pattern, 2 to the 0, we would have to take 2 and divide by 2, and you get 1. That pattern will work no matter what number I put, whether it's 3 to the 4th, 4 to the 4th, 5th to the 5th, and go from there. Everything to the 0 power is 1. Okay? Even a to the 0. A to the 0, 1. B to the 0, 1. Anything to the 0 power equals 1. Now where it gets tricky is when we talk about negatives. If I have negative 4 to the 0 like that, this is 1. But this negative sign out there means negative 1. So if I have negative 5 to the 0 power like that without parentheses, it's only the 5 that's raised to the 0 power. So that would equal negative 1. So what would negative 72 to the 0 power be? Negative 72. Okay. The next thing we're going to talk about are negative exponents. The definition of a negative exponent is this. A non-zero number raised to a negative exponent and yes, you should be copying these notes. If you are not, you better start copying quick. A non-zero number raised to a negative exponent is equal to 1 divided by that number raised to the opposite positive power. So the definition for negative exponents is a non-zero number raised to a negative exponent is equal to 1 divided by that number raised to the opposite positive power. So that sounds really confusing. It's kind of difficult to understand. What I use instead, what helps me remember it, is I think about flipping it. Okay. So I'll give you a minute or so to get caught up. Okay, so if we look at some examples, we're going to start with 3 to the negative 2. Now what I mean by flip it is put a 1 underneath. So 3 to the negative 2, put a 1 underneath, and then flip it over. And when you flip it over, that negative exponent, it becomes a positive. So that 3 to the negative 2 is really 1 over 3 squared. Put a 1 under it, flip it over. In that flipping, that exponent becomes positive. Now we're going to keep going with that because we know 3 squared. What's 3 squared? 9. So 3 to the negative 2 equals 1/9. Put a 1 underneath of it and flip it over. Put a 1, flip it over, make the exponent a positive. So if we look at 4 to the negative 2, put a 1 underneath of it and flip it over. 1 over 4 squared. You are not using a calculator on this. You are doing this without a calculator. 1 over 4 squared. 4 squared is 16. And that's your answer. You put a 1 under it, you flip it over, and you square it or do whatever the exponent is. Okay. So let's look at some actual problems. Let's look at a to the negative 7. A to the negative 7, we have a negative exponent. Now what I always think is negative is bad. You can't have a negative exponent. They're bad. Just think of it that way. Negative, bad, can't have it. So put a 1 underneath of it and flip it over. When you flip it over, the 1 goes on top, the a to the 7th goes on the bottom, and it becomes positive. Now, is there anything more we can do with that? No, because we don't know what a is. So that's our answer, 1 over a to the 7th. So let's look at number 2. A to the negative 3rd, b to the 5th. So this one's a little bit harder because we have a's and b's. Let's focus on the a part. The a part has a negative exponent. So that means that that part has to be flipped over. So that a to the negative 3 is going to jump down to the bottom and be positive. Now, normally I would write that 1 up there, and I am. This b to the 5th, though, b to the 5th is a positive exponent. Positive means that it's good. Positive is good. It can stay where it is. It doesn't have to move. So it's going to stay up there on top. So your answer is 1b to the 5th over a to the 3rd. Now, I generally don't write that 1. I would just write it as b to the 5th over a to the 3rd. And you're done. There's your answer. So let's look at number 3. r to the negative 3 over 7. r to the negative 3 over 7. We're going to think about these two as two separate things. And I'm going to focus on that 7 on the bottom first. That 7 is just plain 7. There's no exponent with it. Not a positive one, not a negative one, nothing. So it's going to stay there. I'm just going to transfer it over. But what about this r to the negative 3? It has a negative exponent, and right now it's on top. So when I flip it, if it's on top, it's going to move to the bottom and become positive. Now when I did that flipping, what's going to go on top? A 1. Remember, anytime you flip, the 1 goes on top. And there's our answer. So problem number 4. G to the 4th over h to the negative 6. These things are separate. You have to look at them that way. Let's look at this g to the 4th. G to the 4th has a positive exponent. Positive is good. Positive means it can stay where it is. So it's going to stay g to the 4th. The h's, though, the h's have a negative 6 exponent, and that's not okay. It's not okay to have a negative exponent, but it's in the bottom. So if it's in the bottom and I flip it, that means it jumps up to the top. And then there's nothing on the bottom. Either you put a 1 or you just leave it as g to the 4th, h to the 6th. So either you put the 1 on the bottom or you just leave it as nothing on the bottom. With the negative exponents, wherever it is, it has to move to the opposite place. So if it's negative on top, it goes to the bottom and becomes positive. If it's on the bottom, it jumps up to the top and becomes positive. Okay? Number 5. Let's look at 7w to the negative 4th. 7w to the negative 4th. Look at 7. The 7 and the w are separate. Look at 7 alone. 7 is just plain 7, so it's going to stay. It doesn't have to move. The w has a negative 4 attached to it, so it does. Right now it's on top, so if it's on top, it has to jump to the bottom and become positive. And that's your answer. Number 6. We're going to get into some that are a lot more complicated. A to the 0, b to the negative 2, c over c to the negative 3, d to the 6th. I'm going to look at each thing separate, starting with this a to the 0. What does a to the 0 equal? Remember, anything to the 0 power equals 1. So that's going to go up there on top, because that's where the a's are. Our b's, b to the negative 2. It's a negative exponent on top. So if it's a negative exponent on top, it has to move to the bottom and become positive. Then I look at my c's. C to the negative 3. It's a negative exponent, and that's not okay. A negative exponent on the bottom is not okay. It has to jump up to the opposite place. So if it's on the bottom, it jumps to the top and becomes positive. Now let's look at our d's. D to the 6th. Is that okay there? Yes, it's okay because it has a positive exponent. Positives are good and can stay. Negatives are bad and have to leave. Number 7. 2x to the 0, y to the negative 7. Again, we look at these things separate. 2 stays 2. X to the 0 means times 1, because that's what that means. Y to the 7th has to move to the bottom. 2 times 1, 2, y to the 7th on the bottom.